Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video we are going to work out a problem on the development of a pentagonal pyramid. A pentagonal pyramid will have a pentagonal base and the highest point is called the vertex. And they have given us the dimensions, and this pyramid is resting on its base on HP with an edge of that base normal to VP. So this is very important both in the development of solids and also in case of the projection of solids. The object has to be placed with an edge of base. Suppose if I write this base edges as A, B, C, D and E with O as the vertex, O dash the front view of that, and here friends, the side AB, which has got a dimension of 30 millimeter, is now perpendicular to VP. And whenever the pyramid is placed on HP on its base, the axis is also perpendicular to HP. Now let's transfer all these points to the front view. We will call this as A dash, B dash. This becomes E dash, C dash, C dash, E dash, D dash. And this is how you got all the 5 points, 2 here, 2 here and 1 there. Friends, the pyramid in this position is cut by a section plane which is normal to VP. Pyramid of S so and so, cut by a section plane SP, normal to VP and inclined at 40 degrees to HP. It is bisecting the axis. Friends, whenever a section plane is normal to VP, it is seen as a line in the front view. So we have to draw the section plane SS passing through the midpoint of the axis. Say the total height is 60 and we can just take 30 mm from the base and we can show this height. This is 60 millimeter and the midpoint is at a height of 30 mm from the base. So you can take from the top or from the base, from the vertex or this. So it's one and the same. So there is a section plane passing through that point, midpoint, inclined at an angle of 40 degrees to HP. So friends, I am going to write a line, a section plane S1, S1, which is inclined at an angle of 40 degrees to HP, which can be seen in the front view. And this is normal to VP very obviously. Now, after the solid is cut by the section plane, we have to retain generally, unless otherwise specified, the bottom portion of the solid and show it by dark lines or visible lines. So I am going to show this part, again this part, and the complete base represented by this horizontal line. So this is the portion P below the section plane for which we need to draw the development of the lateral surface. Friends, what we do? These developments are always drawn to true size. That's a very important concept and every one of you should remember that. Here friends, if you observe the front view of this line OD, the slant edge OD, O dash D dash is here, is the front view. Corresponding top view is OD. And you find that OD is parallel to VP and hence O dash D dash represents the true length of the slant edge. I will mark it as TL. TL is the distance between O dash and D dash. So I'll write down here TL is equal to O dash D dash. So you can just keep a scale and measure what the distance is. So this can be measured. Is the true length. And now friends, taking that true length as the radius, I am going to write a line here. Say this is the true length of that. O is the point, the vertex. And now friends, taking O as center, true length as radius, I am going to draw an arc. That is, this is true length. This is O. And friends, on this arc so drawn, I am going to step up 30 length divisions, 5 because there are 5 edges. Suppose say this is 1, this is the second one, third 30, say this is fourth, and say this is the fifth. So I am going to join the last here, and here friends, all these measurements are 30 millimeter each. From here to here 30, from here to here it is 30, and so on. And now we join this O to all these division points on the arc, like O to this, then second one, next you have got the third one, the fourth one, and the fifth one. Now friends, if you observe the front view, after the section plane has cut the solid, generally we remove the upper portion, the portion above the section plane, and retain the bottom portion for the purpose of development. Now, friends, you can just see here, none of these 5 slant edges are totally eliminated from the body, and hence you can start the development from any point of your choice. So let us go ahead with point A. Mark A, B, C, D, E on this division point. A, B, C, D, and again this point is A. Now friends, these lines OA, OB, OC, OD and OE represent the 5 slant edges of the pyramid in the development. So now, section plane SS is cutting O dash A dash and O dash B dash at this point. Friends, this is not the true length. OA and OB are not in true length. Hence, to get the true length, this point section where it is cutting has to be transferred to the true length line, that is the last line. And take this measurement on OA and OB, because I am taking this point. This has to be taken on OA and OB. So friends, I will mark this point here, OA, a point, similarly on OB, another point, again on OA, another point. So we have got these 2 points, OA and OB. Next friends, the edges O dash C dash and O dash E dash, as you see here, are cut by the section plane here at this point. Again you observe OC and OE are not the true length edges. Hence, that point where the section plane is cutting the solid is to be transferred to the last line, and take that to measurement on this true length slant edge and mark on OC and OE. So both this is OC and this point is OE, friends. So I got the 4 points. Then finally friends, the section plane is cutting the last slant edge O dash D dash at this point. And you know O dash D dash is the true length. Simply take this measurement on that slant edge and mark on the point OD. So friends, you got 1, 2, 3, 4, 5 and this again 1. So you just mark them as 1, 2, 3, 4. So this is point 1, this is 2, this point is 3, point 4, point 5, and again on OA it is point 1. Because when you fold this sector together, you are going to have like that. Now friends, let us join all these points so obtained by straight line. So 1 to 2, I am going to write a horizontal line, and then 2 to 3, an inclined line, 3 to 4, 4 to 5, 5 to 1, and this is how, friends, we join these points. And if you observe the front view here, friend, the portion below the section plane, all these edges are available. So we have to show them by dark line. So I will show this by a dark line. This is a construction part, should be shown by thin line. So this is to be shown by a dark line. This by a dark line here, this dark line, and again 1 to the bottom portion is still existing. We have to show this, all this by full lines, friends, because the base edges of the pyramid are straight, and this arc portion A to B, B to C, all that should be shown but by very thin line, and these slant edges between the cutting point and the base are to be shown by visible lines. And friends, if you observe here, this figure 1, 2, 3, 4, 5, 1, A and all these will give you the development of the part P. If you call this part as P, this is development of P, the portion of the lateral surface of the pentagonal pyramid when it is cut by a section plane normal to VP and inclined at 40 degrees to HP, bisecting the axis of the solid. Friends, I hope that the presentation was interesting. Friends, if you like this video, do share this video and also the information about my YouTube channel, Engineering Drawing by Dr. M.H. Annaiya, with all your friends. Have a wonderful day. Thank you for watching my video.